We're now going to discuss reading microscopes, spectacle-mounted microscopes. Now, when you hear the word microscope, perhaps the first thing that comes to your mind is biology class. And while that is a type of microscope, for our purposes in low vision, we consider microscopes to be spectacle-mounted pair of glasses. I have 6 different pairs sitting here or in view, and what you'll notice is that in at least one of the lenses there's a big bulge of a lens, which is a high-powered magnifier. Basically, the lenses that are used in spectacle-mounted microscopes really have the same optical principles as the stand magnifier and the hand magnifier. The big difference is that it's in a pair of glasses. So magnification, at least for our introductory purposes, is really all the same. It's the same type of a lens. The thing that is different is what holds it, the housing of it. And because it's a stand or a handheld or a spectacle mounted, that allows us to have different types of functional opportunities with that device. Here's a picture of a gentleman who's using a spectacle mounted microscope for the purposes of reading. And one of the very first things you're going to notice is how close it is to his face. With these magnifiers, the more powerful the magnification, the closer it does come to your face. And that, in fact, is its biggest disadvantage, especially if you work with people who have an adventitious visual impairment. They might have 40, 50, 60, 70 even years of reading under their reading experience, and where they read is out at arm's length. They want to be able to sit in their comfortable lazy boy chair, kick back with the Saturday or Sunday newspaper, and enjoy reading that newspaper. In a low vision clinic, we can get just about everyone to be able to read their newspaper. What we won't be able to do is get them to read it the way they used to. They're going to have to read it literally right up, like they're eating it, right up on top of their face. And that is a very disruptive and that's a big problem for a lot of, especially the adventitiously visually impaired. Now, the other problem that we have is that focal distance with this device, as with all the others, is extremely critical. Here's a picture of a gentleman sitting at a table. He's holding his newspaper and he's got it up close to his eye. And if you look at his right thumb, that is creating an indentation in the paper, and his head is creating a shadow on the paper. So here we go back to this major theme of low vision, of illumination. And illumination is always a problem, and even when we solve the problem, it constantly needs management and tweaking. So this gentleman has a couple of problems here. First problem is illumination, and the second problem is the adjustment of the distance between his eye and the page. As his thumb creates that curve, it creates blurriness of print. The blurriness of print can be managed by changing the distance, but what does that mean? It means it's going to slow you down, and that means that you're not going to be very happy with it. Here's a really classic example of how your face gets in the way and your thumb gets in the way, causing problems with illumination. If people have a powerful enough magnifier, for example, a magnifier that causes them to bring it right up to their nose, we have clients who will come in and say they have to wash their face after using their spectacle-mounted glasses. And the reason is because it actually rubs right across their nose. And just as you get ink print on your fingers while you're reading it, it is possible to get that type of print on your nose. So, the solutions that we offer to people to try to make reading more enjoyable: flex arm lamps. A flex arm lamp will allow you to get light on the page and allow you to position it such that your face and the glasses don't get in the way. The other thing that we recommend to folks is that they use some sort of a reading stand. In one of the earlier slides, there was a gentleman who's kind of leaned over his kitchen table, and that's not really a particularly comfortable thing to do. And so getting a reading stand allows the person to position themselves a little bit better. The other thing that you need to recognize is that when you're reading up at that close distance, you're basically breathing dirty air, meaning air that doesn't have as much oxygen in it. You're breathing into the book, you're breathing a lot of your CO2, carbon dioxide, back into your lungs. And so you've got this hot lamp, you're breathing all this compromised air in. A lot of people get sleepy pretty quickly. So by at least getting them to sit up straight, it gives them the greatest opportunity to pull as much good, clean oxygen deep into their lungs as possible. So when we are working with clients who are going to be using a spectacle-mounted reading microscope, rarely do we just give them the microscope. We typically offer them some sort of a flexible arm lamp and some sort of a reading stand or a clipboard that's going to assist them with their reading. Now, while this class primarily deals with adults, I did want to show you one slide of a young child reading with spectacle-mounted microscope. This child is probably, I don't know, maybe 6 years old, 7 years old. And I show that to you because at times there have been medical practitioners, ophthalmologists, or optometrists who've had a bias that children are too young to use optical devices. And the comment I make is that that is a bias that they have which does not hold true. It's a prejudice, essentially, against young children. The argument I would make is that young children, it's really based upon need. It's based upon motivation. I've had kids who are 2, 3, 4 years old who were using magnifiers and were doing quite successful with them. And I've had people who in their 70s and 80s who wouldn't touch one if it was truly the only way to read. They will not change the way they read. They will not use magnifiers to read. So age is not the critical factor. The critical factor is motivation and need. In fact, if you're going to be dealing with children, most of these children are going to have a congenital visual impairment, meaning an impairment at birth. And my argument would be that if you can get that child using these devices before they even start in school, when they get to school, that device will be part of who they are. That will be the only way they know how to function, and it will be integrated within their daily life. And when they get to school, all the other kids will see that that's the device they're using, and there might be a few days of questions, but it doesn't necessarily become a big deal. I can tell you that when we see children who've never used devices, who are all of a sudden in 6th, 7th, 8th grade, 9th grade, the print's now gotten so small that they need high-powered magnifiers, it's extremely difficult, in fact, pretty much impossible to get them to use these things in public. They'll never sit in the classroom and use them because they do not want to stand out. They want to be just like all the other kids. We might get them to use it in their home or in a private study hall, but the moral of the story is that if that kid starts with it before they actually get to school, they have a much greater opportunity and chance of succeeding and integrating it into their life as they go through school, rather than the child who is never used a device until they get into the middle school years. So that's spectacle-mounted magnifiers. Now, the major advantage of a spectacle-mounted magnifier is that if you are able to deal with the issues of illumination and posture, if you compare the visual field of a spectacle-mounted magnifier to the standard handheld magnifier, what you'll find is that the visual field is the largest. And if you go back to my earlier theme of the larger the field, the easier it is to use, what you will recognize or conclude then is that spectacle-mounted magnifiers, if you can learn to adapt to them, actually become the easiest to use because they have the largest field of view. Now, here's why they have the largest field of view. If you take your hand and make a circle with it, like a donut, with your index finger and your thumb, put it up to your eye and close one eye, and just look in the distance, in whatever room you're in right now, and establish what the visual field is that you have. Then slowly move your finger, keeping it the same size and shape, move it away from your eye, and notice what happens to your visual field as you move the finger away from your eye and closer to your eye. What you should experience is a change in your visual field. Your visual field should be getting smaller as you go from your eye and you push it away. Your visual field should actually decrease in size. So if you think about a 5-powered handheld magnifier and where a person will most likely hold that, they'll hold that out at a normal working distance, and that will give them a certain visual field. If we took that same 5-powered magnifier and put it into a pair of glasses, by definition, that glasses are on their face, on their nose, right in front of their eye, and that's going to give them a much larger field of view. So a 5-powered hand magnifier and a 5-powered pair of spectacle microscopes, in fact, will have the same or very similar visual field. However, because the spectacle microscope forces them to have it right up next to their eye, functionally they experience a larger visual field. Oftentimes in clinic, we will give people as using my example, a 5-powered magnifier in a pair of microscopes, spectacle-mounted microscopes. We'll have them read a little bit, and they will really resist. They'll just be incredibly unhappy about that working distance. They don't want to feel like they're having to eat their newspaper. And they'll say, can't you give me something that lets me get out at a more comfortable or normal working distance? We'll give them a 5-powered stand magnifier. And they will be using that 5-powered stand magnifier. When they leave the clinic, they'll be holding that 5-powered stand magnifier out at the same distance as if they were reading normally, meaning at an arm's length. And they'll be happy. We'll let them borrow that. 3 weeks later, they'll come back to the clinic and they'll be holding that stand magnifier right up against their glasses. And they'll be reading that way. And they'll say, can't you give me a pair of glasses that will do the same thing as this stand magnifier? And we'll say, sure, we can give you that pair of glasses. We'll give them this pair of 5-powered magnifiers, and they'll read right up here. And they'll say, geez, why didn't you give that to me in the first place? What has happened is that person did not realize that over the course of the 2 or 3 weeks that they were working with this device, that they realized that the closer I get it, what happens? The bigger my visual field gets. Go back to your finger example of, if you move your little circle back and forth, you increase your visual field just by moving it back and forth. And while this patient is not expressing it that way, from the point of view of the words, their behavior is demonstrating that they recognize that the closer I get this to my eye, the bigger my field of view. And we know that the bigger your field of view, the larger your field of view, the easier it is to use the device.